All right. Equal matrices have the same dimensions and have equal corresponding elements. Those elements in the same relative position. So if you have two matrices that are equal, then every single piece of the matrix is also equal, meaning every element that corresponds to the element in the other matrix is equal. This is one of the ways that you're going to solve equations with matrices, is something like this. They have told us that this matrix is equal to this matrix, which means each corresponding element, 1, 1, 1, 2, just if you were to follow those columns and rows across, then you could figure out what all the small variables within them represent. And so like for this one, I have this is in row 1, column 1, which means these two are equal. So A equals 7. 2B would be equal to -8. 3 would be equal to C minus 5. And 3D would be equal to D plus 6. All right. And so if they wanted me to find the values of these variables that are in there, you're literally just solving. A was given to us. B, we're going to divide both sides by 2. C, we are going to add 5. And D, we're going to subtract that 1D over and then divide by 2. And you should see that D equals 3. And so if you know they're equal, you can do your properties of equality and just solve very simple equations on the inside that represent those variables. All right, matrix addition and subtraction. Matrix addition and subtraction. So now we're talking about the entire matrix. If you're solving elements within it, then you're just using basic algebra equation solving. You can actually add or subtract the entire matrix, all right? To add or subtract matrices with the same dimensions, add or subtract their corresponding elements. In order for you to be able to add or subtract a matrix, they have to have the same dimensions. If they don't have the same dimensions, then when you go to add or subtract, there will be an element missing and you won't be able to do it. And so the first thing you have to establish is, can I add or subtract these? So the first thing you want to figure out is your dimensions. My dimensions of A, well, that's a 2 by 3. My dimensions of B, that's a 2 by 3. That automatically tells me I can add or subtract them. All right. And then your same properties apply, which we're going to look at. If they want me to add A and B, then that means they want me to take the entire matrix here, the entire matrix A and the entire matrix B, and add the corresponding elements. All right. Very simple. I'm going to say 2 plus 4, and my answer here is going to be another matrix by the same dimensions. 2 plus 4 is 6. 7 plus 2 is 9. 0 plus -1 is -1, and that's my first row. And then 3 plus 1 is 4. 1 plus -2, -1, and 5 plus 3 is 8. Very, very simple, right? And then the same is true if I wanted to subtract. If I wanted to subtract these, then I would just take those and I would do subtraction. And so I would say the same two matrices and I would subtract the elements. The only thing I would say to watch with subtraction is your positives and negatives. Because remember, you are subtracting across, not adding. So we have 2 minus 4. The biggest problem I see here is people getting our negatives wrong. This is 0 minus a -1. Minus a -1. So it's like +1, right? And then the rest of them, obviously, 3 minus 1, that's going to be 2. But then we have 1 minus a -2. So that's 1 plus 2, right? So just watch your positives and negatives when you're subtracting. Most of the time people are okay with adding, but when you're subtracting, you are subtracting a negative sometimes. And so make sure you pay attention to your rules there. But other than that, adding and subtracting is pretty straightforward. I want to talk about the additive inverse just because it's going to come into play when we start solving equations, but just like in regular addition, additive inverse or additive identity really is part of the properties that allow you to do the addition and subtraction across the equal sign. And so in matrices, if you add zeros, like if an entire matrix is 0, that's the additive identity. Because if you add all zeros to a matrix, none of the elements are going to change, right? The identity doesn't change. Additive inverse, if you were to add the opposite of all of your numbers, then it would zero it out. And so just like in regular solving of equations, you can actually add or subtract an entire matrix across the equal sign to solve for another matrix, all right? And the same rules apply. Whatever you add to one side, you add to the other. Adding the inverse will zero it out. It doesn't matter what order you add it in because you're just adding two numbers within it, so order doesn't matter. It doesn't matter for grouping if it's all addition. And closure, if you add, you have to have the same dimensions, and so your answer will be the dimensions that you started with when you add matrices. And so we use this when we're solving equations. We have one more thing that we do with matrices that we do with regular numbers, and it's multiplication, okay? And so there are two types of multiplication. The one we're going to talk about today is called scalar multiplication. The reason it's called scalar is because you are taking the matrix and you are increasing every single element by the same scale factor, okay? This is exactly what's used when you blow up a picture, right? If you make it 150%, then you are multiplying every piece of that picture by the 1.5. If you don't multiply all pieces, your picture is going to be skewed. And so for scalar multiplication, you are literally taking every piece of the element, every element, and multiplying by it a scale. And so it will look just like this. They will have a scale factor in front of it multiplied by a specific matrix. And they want you to take this matrix and multiply everything by this number. It's like a coefficient, but for a matrix, all right? And so if I were to do this first one, 1/2 A, I'm going to multiply every element in here by 1/2. I will have a 2 by 2 matrix when I'm done. 4 times 1/2 is 2. 0 times 1/2 is 0. 2 times 1/2 is 1. 5 times 1/2 is 5/2, right? This is true for all of these. If I were to take B and multiply everything, I would take everything and multiply by -5. And then you can get a combination of them. You are going to use order of operations, just like you would. Meaning, I will do my scalar multiplication first, then I will do my addition subtraction second. And so if I were to do this, I would take my 3 times my A first, and then I would take my 2 times my B, and then I would do my subtraction here, okay? And so you would just now subtract across, right? And so 12 minus 4, 0 minus 8, 6 minus 2, 15 minus 6, right? And then this would be my answer to do that scalar and that subtraction, all right? All right, so you can solve equations. You'll notice the difference between this and the first one we did is it is a capital letter X, right? So when you see that capital letter, your answer is going to be a matrix, all right? It's not going to be one number like it was for the first example. You're not solving for an element within it. You are solving for an entire matrix as your answer. But you are really going to do this exactly the way you would solve. If I had some number minus 2x equals some number, I would just solve for x, okay? And so you're going to do that by subtracting your matrix over, dividing every element by -2. So it is the same exact process. You're just moving an entire matrix at this point. And so I am going to follow the same rules that I would if I were solving an equation. I would take the matrix and I would subtract the entire thing from both sides, right? And so I'd subtract it from this side and then subtract it from the other side. And just like in regular algebra here, it cancels. That's what we talked about. If you subtract it, the inverse cancels each other, just like if that were a 5 and I subtracted a 5. Because I am taking each element, 2 minus 2, 0, 1 minus 1, 0, 3 minus 3. I'm subtracting each one of these. This whole thing zeroes out, right? And so that's my first step. I do have a negative 2x left. So I would have negative 2 x as in a matrix x, and then I would just subtract these. And so on the right side here, I am going to have a matrix, 3 minus 2, 5 minus 1, 2 minus 3, 1 minus 3, 4 minus 5, 1 minus 1. And then I'm going to do exactly what you would think. So if you can scalar multiply by negative 1/2 is the same thing as dividing everything by negative 2 on the other side. And so if I'm dividing everything by negative 2, that's like multiplying everything by negative 1/2, which I can do. It's scalar. So my matrix is going to look like this. I have 1 divided by negative 2, 4 divided by negative 2, negative 1 divided by negative 2, negative 2 divided by negative 2, negative 1 divided by negative 2, and 0 divided by anything, right? And so that would be my answer to what the matrix X would be. And just like algebra, you could plug it back in and solve. You could plug it back here, multiply everything by negative 2, subtract it from this, and you would get your answer. And so you're doing exactly what you would do in regular algebra. Solving for the variable that you are looking for, move everything that's not with the variable first, divide or multiply depending on what you're doing, and then you'll solve for your variable. It's just a multi-step operation here.